My name is Rajeev Oduri. I'm a director of data science. The last 10 years, I've been primarily focusing on marketing, within marketing, primarily on experimentation. So I know Pete for some time now. I know he's your professor, but he's also my mentor. So he gives a lot of great advice on how to navigate career and all of that. And I'm really grateful for this opportunity. And thanks, Pete, for inviting me to guest lecture in your class. And I can say this confidently, you have the best from the industry teaching you this class. You all should be lucky. I wish I had a professor who worked in the industry and then taught us when I was in school. So you guys are definitely luckier. And then I prepared a slide for my introduction. I'll just quickly go through this so that you know a little bit about my background. My name is Rajeev Oduri. I'm a senior AI and data science leader in MarTech, AdTech, and retail media. So if you divide my last 11 years of experience in marketing, so for the first 8 years, I was primarily working in marketing technology. And then for the last 2 years, my focus has shifted towards AdTech and retail media. That's the new evolving area. So I thought I should get into that space, like very similar. But for the first 8 years, I was in the marketing space. In the last 2-3 years, I went on the publishing side. It's the same thing, but we are selling ads versus buying. Slight shift, but very similar. So I've been working in this industry for 10 plus years for three of the biggest Fortune 500 companies in US, mostly in retail. So right now I lead growth initiatives for a top 10 retail media business in US, focusing on ad product testing, machine learning driven targeting, lifetime value measurement, and clean rooms. I also built platforms because you don't always want to just focus on analysis. It's important to build platforms. And I realized that like halfway through my career and then started building products which are scalable. The two of the key products I built are multi-touch attribution and holistic experimentation. And Pete and I, we have collaborated on an article on holistic experimentation as well, which will be published later. And in 2020, my team won AMA Genius Award, which is from the Association of National Advertisers for marketing analytics excellence for work in integrating random control trials with machine learning uplift models to try precision marketing. And then for the last 1 year, I've been collaborating with IAB committees. IAB is the Interactive Advertising Bureau. They set standards for marketing measurement and how different media agencies and media publishers operate and then provide a cleaner measurement for the advertisers. I've been part of those committees, and then I was able to collaborate on retail media measurement guidelines and in-store measurement guidelines. And recently, the Gen AI playbook for advertising. Really proud of the work that's happening at IAB, and then I'm glad I was part of it. And I'm also a jury member for the ICOM Data Creativity Awards. So a lot of the companies like Kantar, analytics companies like Kantar, Tredence, and also retailers like Target, Walmart, and also many other companies like McDonald's and Starbucks, they're all innovating in marketing. Innovation happens in academia and also in the industry. These awards are for the companies innovating in marketing using AI and all the latest technologies. They submit their nominations, and then we review these nominations and score them based on creativity, innovation, and impact and broader impact they can create for the industry. I happen to be a judge in those awards. I learn a lot of new things that's happening around the industry in addition to the work I'm doing right now in my day-to-day job. So let's get into the presentation. There are so many quotes about why experimentation is important. I know this is the right class to talk about. So I know you guys are in the experimentation and causal inference course. So one quote that stuck with me was from Carl Pearson. He says, there is no shortcut to truth. You can learn so much from the data you see every day, but not everything is true or 100% accurate. So anything you say as truth, it has to be vetted with the scientific method. That's where the experimentation and causal inference comes in. So what is marketing experimentation? It is a structured approach to test your hypothesis and then prove that whatever you're trying to measure is causal. And then you can build that causal relationship with what you're testing to what you're measuring. So I don't have to tell you guys all the key benefits. It's data-driven marketing or decision-making in business we are trying to drive. So experimentation is a key function you need to leverage. So there are so many tools out there which can help you take smarter decisions. A lot of the media publishers provide reporting using last touch attribution. For example, if you go to Facebook Ad Manager or Google Ad Manager or any other ads manager, there is a lot of automation around the reports you can see. So most of the marketing decisions are taken based on last touch attribution results, or even the planning that happens in marketing, the top-down planning is done based on media mix models. So experimentation is used rarely. The reason is it's expensive, time consuming, and it's not always feasible to set up experiments. So what should we do? Should we try to run experiments in every single campaign we're running to make sure that the decisions we're taking are causal and then are true? And then the impact we're driving is actually believable, that marketing is driving all of that? Or should we just keep moving towards the tools we have from last touch attribution or first touch attribution or the media mix models without any validation? So my observation in the last 10 years is you have to embrace both, because experimentations are great, but they cannot scale up to where you can run experiments for every single campaign you're running. So you need to embrace your reporting tools from all these basic tracking you have, and then try to vet and triangulate those reports with experiments. Time to time, you run experiments across different channels, different campaigns, so that you can always go back and then adjust and calibrate your basic reporting you have. So that way you can embrace the scale, and also you can embrace the scientific rigor you get from the experiments. So that's what I want to focus on today. So this is the experimentation life cycle from the practical standpoint. This is what I practice in my day-to-day role and how I run experiments. I start with research and hypothesizing the problem. Most often, the business marketers who are running campaigns, they have some hypothesis in their mind. For example, a direct mail marketer might want to test, hey, I'm spending 50 cents to send a direct mail to my customers. Is it really driving true incrementality, or is it all passive attribution we are measuring, and then is it truly driving top line business impact? Or an email marketer might come to you and then ask for helping with, hey, I have these 10 great ideas as subject lines for my first year engagement emails. How do I know which one works best? So what are the key metrics we need to use? Is it open rate? Is it click-through rate or conversion rate? So there are so many hypotheses that can evolve from the business. And then if you have bandwidth, you can also come up with some new hypothesis. Hey, I know we're spending too much money in direct mail, but we have this high engagement in email. Like 10% of the customers open the email and then 5% of them click and then purchase. We have this strong evidence from my Adobe last touch attribution data and also email engagement data. I want to test for these customers to see if sending direct mail really makes sense. I want to test this hypothesis, and then no one will object to you, because if you show them some future outlook that this is going to drive longer operational efficiencies and also long-term impact for the business. This is the hypothesis layer. This is where all the new ideas evolve. And then you get into the design layer. Once you get the business commitment, you get into the design layer. Design is really important because you can easily get tempted to just set up the experiment and then try to measure it later. If you don't have a proper design, most of the times what happens is you'll end up seeing flat results. The time you invest in experimenting and then the resources you put in towards this, and then if you hold out direct mail from sending to some customers, and then you're also leaving so much opportunity on the table, right? If it truly works, then you're just leaving money on the table. So this opportunity cost is very expensive. So you need to have proper design in place. Design means like you run your power analysis, and then you have some expectations on the lift you want to measure. So with the proper design, you can come up with certain test parameters, like how long you need to run the test and how many people you need to send it to. And then what are the right offers? Do you have all that? Do you have all the right parameters for the design? Then you launch the test. Launching, it can happen with the help of your broader stakeholders, but you need to ensure there is nothing like a cross-contamination between the stores you're testing or between the members you're testing. If you're running a membership organization, if each membership has like multiple individuals, you want to make sure that you do the experiment at a membership level, because within the same household or membership, there can be some cross contamination to ensure all those things are taken care. And then you monitor, optimize, and then analyze and experiment. That's practical like stages I personally implement, and then it has helped me get most out of the experimentation. This is a cheat sheet I created for myself. I'm happy to share that with you. My version is a little more complicated, but this is a simpler version. If you're running an experimentation team, or if your day-to-day job is experimentation, I highly suggest creating something similar for you, but you can leverage what I have here as well. This would help you to streamline your thoughts on what's practically possible in experimentation, and then what are the different tools you have for your own problem, because you cannot always run an analysis at a customer level. So there are some analysis, they have to be done at a geo level or market. And you cannot always do a holdout test. Means you cannot always do an A/B test. So there are different tools out there. You can ask ChatGPT, it can suggest you some things, but I'm trying to give you a practical perspective, and then the cheat sheet I created myself. It took me 10 years to create this, but this will help you come to a starting conclusion about what methodologies you can leverage, and then streamline your thoughts about what are the different tools out there, and then how you can fit your problem into this framework, and then see how you can come up with a methodology that works for you. First question I'll ask myself when getting into a causal inference or experimentation problem is, can we implement a randomized or holdout test? The gold star or North Star, gold standard or North Star experiment you can run is with the holdout or an A/B test. It doesn't need to be holdout. If you're testing two different creatives, you don't need to hold out anything, or you create an A/B groups and then test those two things, right? Try to be on the upper side of this chart as much as possible, so that it's easy to analyze the data, and also the results you get from that are North Star compared to the non-holdout test. If your answer is yes, then is it at a customer level? Do I have access to the customer level data, or I have access to geo or market level data? If your answer is customer level data, then the next question is where you are. If you are working for a company with hundreds of thousands of records with customers, then you can be very certain about using parametric tests like t-tests or tests of proportions. So that will do the job. And then if you are working for a B2B business where you don't have hundreds of thousands of customers, but maybe 10,000 or less, parametric methods may not work. You can test for a normality and all of that, and then see if the parametric tests work. Then you need to go to the non-parametric. Non-parametric tests sounds complicated, but they're not really that complicated. So you can use basic bootstrapping and Monte Carlo simulations and run some Python program. And then the basic here is you don't assume any parameters in your testing. You come up with your own distribution of null hypothesis and then try to look for your expected lift there. We can spend more time on these tests in a different class, but I'll just keep it at a high level. If you don't have access to customer level data, then you can leverage geo or store or market level data to do the similar analysis. The trick here is in the geo tests, you cannot just do random test versus control and then conduct an analysis, because you have very less number of test subjects in geo tests. For example, if you're running a store business, like you probably have a few thousands of stores or even less. If you just do randomization, it won't do the job because each store is different. So you have to do some additional matching on top of the randomization you do. That's where you have to use some non-parametric tools there and then account for all the noise in the data to come up with your own null hypothesis and null distributions. So this is again similar to how I described the non-parametric test at the customer level. There's so many tools out there. If you're working for a large company, most often they have these tools like APT, Applied Predictive Technologies. They're owned by MasterCard now, so you can leverage those tools. And then Google and Facebook, they came up with great geotesting tools. All you need to do is you prepare your data sets and features at a store level, and then you just upload them into the platform, and then it can analyze it for you. So if you cannot, let's go to the bottom of the chart. If you cannot do a holdout test, then again, you ask the question, like, do I have customer level data or the geo level data? So if you have customer level data, and then if you have access to the entire population of the data, And then you can leverage synthetic control matching or propensity score matching techniques so that you come up with the control group. Although you don't have the control group, you can come up with the control group using synthetic control matching. So what you do is, leading up to the intervention of the campaign, you create features and then you try to match that against the rest of the universe who are not exposed to that intervention or campaign. So you can read about these techniques. I'm not going to dwell a lot on this slide. Just give you a few details about the other things, and then we'll go to there. We have concrete examples where I can demonstrate some of these. So the panel-based data, for example, you're running a survey. You cannot send survey to everybody in your database or who's exposed to your campaign. And not everyone who you send that survey to will respond, right? So you have a panel data. If you have 100,000 customers, your survey response, you may get it from maybe 3,000 customers, right? So in that case, whatever you derive from that panel is not representative of your entire database. So then you have to do some matching and weighting based on some characteristics of the panel versus your customer base. So you can use demographic data or behavioral attributes and then do that matching so that you can infer that, here, learn this from this panel. And then this panel has a different mix of customers compared to my population. But when I scale this back to my population, this is what I'm learning. And then the last one is, again, this is also a geo testing type of a problem. But in this case, you don't get to choose your test groups or control groups because you're not able to design this, because this is not a holdout test, right? So in this case, what you can do is you just let the work happen naturally the way it is. And then based on the natural data you collect, and then you try to come up with the counterfactual. So based on time series data you have, and then different combinations of how marketing is happening across different geos. So you can leverage all these advanced packages like Google's introduced Bayesian structural time series package. I have a slide on how to demonstrate that. But here, the key is you don't get to design this geo test, but you have data like naturally available based on how things are working within your marketing department or your business in general, and then use that naturally available data and then come up with the counterfactuals. Counterfactual means what could have happened without this campaign? What could have happened without this intervention? And then try to come up with an answer which is renewable and then causal. Any questions on this tree here before we get into? I have specific examples, and I'm not going to cover everything in here, but at least some of the major ones I'll demonstrate with specific examples.
Looks like we'll have questions at the end, probably.
Okay, sounds good. You can always ask me for any specific thing in here. I'm going to cover 4 or 5 examples, so you'll get some more clarity on some of these, and then we can spend more time later. So this is a basic example. This is an A/B test. Most of the marketing experimentation problems can be solved using this. If you have only limited time, if your primary job is like marketing analytics or strategy, and then experimentation is secondary while you're working. So if you want to just learn one thing, you should just learn this. The rest is when you want to get into more advanced experimentation. And then if your day-to-day job is experimentation like me, then you should focus on the other things. But if you just only want to learn one thing about experimentation, you should learn this. So this will do most of the job. So this is basic A/B testing, where you get to design the tests and then assign your test subjects to different groups. Like it can be 2 groups or 3 groups or as many groups as you wish. So things like, if you're running a direct mail program, you all know direct mail is expensive, right? I know the banks send direct mails left and right, but it's very expensive. It costs 50 cents to $1 to send a direct mail. And the email doesn't look expensive, but it is expensive because if you keep sending emails to your customers like 10 times a day, they will unsubscribe. It's just bad for your business. So you need to run some experiment to find what's the right frequency for that. And then you may be running offers, whether it's 10% is rich enough or 20% offer is rich enough, you don't know. So for all these types of to answer all these types of questions, so you can leverage basic A/B testing. The randomization is the key here. If you're able to do that randomization, And then if you can do some basic power analysis, so if you're expecting certain lift, you need to make sure that you have enough sample size, and then you can run this test long enough so that you can detect the signals you're trying to measure. So that will do the job. So like I said before, if you're working for a B2C company where you have hundreds of thousands of customers, you can use this test confidently. You don't have to go to any advanced non-parametric testing or anything. The basic t-test and test of proportions will work. Yeah. Any questions on this? Do you want me to go a little bit deeper on a specific example, or are we good to go to the next slide?
We're good.
The second one, this one is interesting because I'll give you an example of a high value action. So in marketing, we are always focused too much on setting up experiments at a campaign level and then try to measure the impact of marketing, right? Even before getting into marketing, there are some actions you need to measure the impact on. For example, if you have a premium subscription service for your company, having somebody to subscribe for that subscription is much more valuable than getting them to make a one-time transaction. Or if you have a mobile app for your business, wouldn't you want your customers to use the mobile app versus an web or a desktop? So wouldn't they remain loyal? And imagine you're running Amazon business, right? So who would spend more? People who has the Amazon app or people who just use desktop or mobile app, mobile web? Of course, the customers with the mobile app, right? So you don't always get stuck on running marketing campaigns and then driving impact from just those campaigns and then somebody clicks on it and then purchase, right? So you also need to focus on driving high value actions. So that's where it gets interesting. But how do you measure the impact of high value action? I know we can measure impact of marketing because you can send some people the marketing message and don't send to some people, and then you can always see the difference, right? So it's easy. Relative difference is easy. You can do that based on the previous slide I have explained, right? But how do you measure the impact of the action itself? So you cannot eliminate that mobile app from the iOS store or Android store, right? That's not possible. I don't know if it's possible, but you don't want to do that because you're going to lose a lot of organic app installs, right? This is where the causal inference comes in. I don't try to force fit causal inference wherever I want to because it's fancy. There is a real need for causal inference in instances like this. I had to deal with the situation like this in my previous role where we were asked to measure the impact of an app install or a premium subscription. So the previous analysis before this causal inference analysis was comparing people who signed up for a premium subscription to the general population. It showed the impact was $2,000, $2,000. No one believed it. So then my team was asked to see what's the realistic number there. And what we did was we created a feature, like a feature library for all the people who signed up for that premium subscription, and also created similar features for the rest of the universe, like general population. And then we tried to match the premium signups to the non-premium signups, and then create a synthetic control. So that means like we have a true baseline right now. Then that impact of $2,000-$3,000 came down to a few hundreds, and then which was believable, and also it's accurate because we were matching the baseline right now. So now the leadership started deleting those results. So then what we did was, hey, now we all believe that this high value action is important for our business in the long run, right? So let's invest money into getting these high value actions, more of these high value actions through marketing. So you're already naturally getting installs or subscriptions. So let's spend more money in marketing to get more incremental signups because we know there is long-term value in that. So for that marketing piece of the incremental measurement, you can always leverage the A/B testing I have described in the next slide. So you can leverage this for any number of high-value actions. So that's where you can use a combination of experimentation and then causal inference to drive your business forward. Any questions before we move forward to the next slide? Okay, so this is an example of a geo-matched market test. Geo testing is important in the cases where you don't have access to customer level data. So imagine yourself trying to measure the impact of a radio campaign or broadcast TV campaign or newspapers, or recently there are like a lot of shared mails because direct mail is expensive. You have probably received some mail back, direct mails, which are shared mails. So you don't always have access to the customer level data in these cases. So do we just believe that this works, or do we need to do any experimentation there? It depends on how much you're spending. If you're spending millions of dollars in radio, broadcast TV, and these newspapers, you don't have access to direct customer engagement data. So you better run some geo experiments. And the decisions you have to take while running the geo experiments is, should I run it at a store level, or should I run it at the DMA level or CBSA level, or even zip code level, right? It depends on how dense your store or your point of sale network is. If you have a dense network of stores, there will be cross-contamination between the stores or zip codes, so which can contaminate the test. For example, for a major retailer, they have 10,000 stores in US. So they're probably stores where most of the customers buying from multiple stores. So if you happen to design a test at the store level for this company, then you will get into a situation where the stores next to each other, maybe in test and control groups, will contaminate the experiment. So you need to be conscious about how your business model is, and then how dense your point of sale locations are, and then design the geo test at that level. But the challenge is, the less granular you are setting up these experiments, means if you're setting up an experiment at a DMA level, you barely have like 200 DMAs in US, you lose the statistical power. So you have to find what's the best thing for your business while trying to save time and money in investing in these experiments. So depending on how dense or less dense your point of sale locations are, and then what your feasibility or initial analysis you're telling you, so you choose the right methodology there. And then after choosing the test subject, whether it's a DMA or a CBSA or a store or a POS location, then you have to come up with all the attributes for your stores or locations. And you can leverage a combination of demographics data, the median population size, the median population for that location, or a population growth, and then a population across different demographics, and then households with kids and households with pets, and also the baseline sales that are happening in those POS locations across different categories. You need to make sure you don't have any confounders in your analysis. So you first draw a causal graph of, hey, I'm testing this direct mail campaign across these categories. What are the features that can impact this campaign? So imagine anything that can influence this campaign. So you have to balance on those input variables. Once you start collecting all the causal graphs in your mind, then you can start creating all those attributes in this at the geo level. And then the initial basic exploratory analysis can tell you whether all those things you thought about impacting this output, it's worth it or not. You can run a basic regression model even before running the experiment. You can already tell so much about what variables can influence this output. Whatever you can think will impact your output should be used in matching. So otherwise, you can lead to a lot of bias in your analysis. For example, if people like Bill Gates are living in certain geolocation, and you have another geolocation where like you have a lot of middle class or people with certain median income living there, it's not fair to compare those two geos in your analysis, because the fact that there are a lot of affluent folks living in one region, so they're already well equipped to sell more there. So the impact you're going to measure there is probably not because of the campaign you're running. It's probably because of the people who are living there. They have a high tendency to purchase. So you need to draw that causal graph and then make sure that you use all the data in your matching, and then ensure that there is no bias in your analysis. Yeah. So the next one is, this is a little bit nuanced example where you often don't get into the situation. As you go up in your career, you will be asked to measure or help senior executive leaders with buy or build decisions, or should I build this feature in-house or should I outsource it? If you can answer those questions with experiments or basic causal inference techniques like synthetic control matching or geotesting, go ahead and do that. But sometimes it is not possible. So I was in a situation where I was asked to help with a decision where should we outsource our SEM? SEM is search engine marketing. Should we outsource this program to some other vendor who will charge a bounty, like $20 fee for each acquisition we were trying to make? Or should we keep this in-house? So the reason why the marketing team wanted to outsource this was some of the personalization features were a little delayed due to some tech. They wanted to get this done quickly and then grow the business quickly. And then there was a vendor pitched for this feature, but he was going to charge $20 bounty fees, which was going to cost us millions of dollars extra, right? So this is a tough question and a one-off question you need to answer. So what we did was we tried to find every possible way to do an experiment. It was impossible. Like SEM program, if you're running multiple campaigns with different parameters, you can use like Google D&D. Google has drafts and experiments platform. You can run an experiment there. And then you can create multiple campaigns with different parameters and you get results from it. Or Google also has this geo-testing feature. I can identify a list of zip codes I want to target and then list of zip codes I don't want to target. And then I can run campaigns on some zip codes and not on others and then do a measurement. But in this case, your baseline is your in-house search engine marketing team is running the campaign. And then your challenge, and then your variation is your vendor is running that campaign. So they're happening in two different Google accounts. It's impossible to run this test. So we had to find a causal inference technique which can help us answer this question. So what we did here was we made a lot of assumptions. We used the time series data. So we plotted time series data from when I was working on this, like several years ago. We plotted the time series data from the past couple of years across different marketing channels. What are the acquisitions you're getting? And then we saw a strong correlation between the channels. We thought maybe we should leverage the correlation between different marketing channels and then try to predict what would happen in SEM if we go down the path of in-house campaigning the way you do in-house versus, and then let's test this vendor for 2 months or 3 months and then see what they have to come up with. So we let that vendor run this campaign for a few months. And then we did it. And then what would have happened if we did it in-house was a prediction from the model, which is like a counterfactual. So we leveraged Bayesian, Google's Bayesian structural time series package for this. And then we were able to prove that there is not enough lift we're going to get from outsourcing this to justify the incremental spend you're going to have to pay this vendor. So this methodology may not work in every case. If you are trying to prove the absolute impact of what this vendor can do, it's very hard. But because the statistical power is not that great for this analysis. So if you can see on the left-hand side chart, right? So we ran some simulations with some simulated data. So what model suggested was the end lift has to be at least 20% for this model to show statistical significance. Luckily, the impact you have to create to justify the millions of dollars of incremental spend you need to make this vendor was higher than 20%. Then this model is good enough for us to take this buy or build decision. But this is not good enough if you're only paying like $500K to this vendor, right? This model cannot really prove that, hey, you cannot. Like this model would have said that, hey, we don't know. It's okay. It's $500K. You can go ahead and spend it. But we cannot really tell you that the spender is usually driving $500K impact. So wherever you have these big spend decisions where you're expecting very high lift, it's okay to leverage some techniques like this. But this was a creative and then bootstrap technique. Worked in this case. I'm really happy that it worked in this case. If it's the other way around, if you need to bring something in-house, then it can be challenging because it's hard to prove the impacts that are small. But we had to make a lot of assumptions because SEM and SEO are correlated, right? It's not entirely, how I can say this. Do you know SEM and SEO related? So when you run a search engine marketing campaign, you will write, right? if you're running an SEM campaign, you might cannibalize some of the SEO traffic you can get. Like an SEO is organic traffic you get on search engines. And SEM is the paid media. So you may be at the top of the search engine results, but if you pay Google or Bing more, they'll put you at the top, right? So when you run marketing, so you're gonna cannibalize some of your SEO. So I know it was not entirely accurate to leverage SEO in the SEM predictions, but we had to make some assumptions so that we can at least say through or maybe 80% there in terms of the causality. So these are the decisions you need to take. The key is we need to be as scientific as possible, but also we need to understand the business sensitivity around how fast you need to answer these questions. So this was good enough analysis to answer this specific question, but I won't say that all the assumptions are all kind of 100% accurate, but we were able to get the job done.
Hey, Rajeev, I have a question on this one. So this seems like a really big deal, right? I imagine this was a very big question in your business, right?
Yeah.
Was this one of the most important things you and your team worked on, say, in the last year?
Yeah, one of the few things I would say. Yeah, this was like a one-time decision. I like one-time decision making when it's really big, but I'm a big fan of platforms where you can make impact long-term. And then even if you left the team, the platform stays and then more decisions are taken. So platforms are like always more impactful. I kind of mixed thoughts about this. But in this one, I was really happy about this because it was a big decision. It really helped save a ton of money. But I'm also excited about the other things about platforms. Like, for example, the first that I covered on A/B testing was able to build a direct mail experimentation platform. And it's been running for so many years already. Done this at Office Depot as well. That's 9 years ago. That's still running. They tell me it's really working well for them. Yeah, so it's all about the price. If it's like a one-time analysis, the price is really high. I'm excited about it. If it's a platform, I don't care too much about whether I'm saving email frequency for some customers and then improving their customer experience. That cannot be measured through monetary benefits, but you have less unsubscribers. But imagine that's running all the time, and then how many member experiences we can save, and then that will result in overall health for your CRM file. I'm excited about those as well because you can easily quantify them over time. As I can say that I've run like 300 experiments and then now I know the right frequency for this email channel, which is saving a ton of money over time.
Great.
The last one, this is a very interesting area. Spend some time on this. I'll be presenting about this in the Informs Marketing Science Conference later this year as well. They accepted my proposal. We discussed so far a lot of things which you have full control on, right? So direct mail, email, those are all your own and operated media. So you select, let's say you select 10 million customers, you want to send an email to direct mail. Everyone will receive it, right? Maybe there will be some fall off like 5% or less than that. But if you're running a Facebook campaign or a Google campaign or any other digital campaign, right? You don't have full control of who's actually exposed to these ads. You start with the 10 million universe like you do with email campaigns or direct mail campaigns. And then once you start matching your customer database with the Facebook's customer database, you lose maybe half or even more than that. And then not everyone who matches to Facebook will be active on the day you're running the campaign. And then there is bidding. So you cannot win every bid because everybody in this world are trying that bid, right? Because they wanted to drive conversions for their businesses. What I'm trying to explain here is there is a big fall off, like in a waterfall. Like you start with 10 million, you probably end up showing ads to maybe, just making this up, 200,000 or maybe 500,000, depending on your budget, members or customers. So this is where it gets challenging. You think you want to measure impact of these campaigns by setting up a control group or a AB groups or whatever, but it will be diluted at that level. If you do a 50-50 split for your initial targeting list, and then if only a fraction of your test group receives or exposed to the campaign, then you cannot really measure anything from this data because how much of an influence those 100,000 people who are exposed to those ads will have on this entire 5 million universe, right? So in the scheme of large things, the impact you draw will be diluted. You're trying to measure the depth of a ocean has changed by just throwing a bucket of water in the ocean, right? If you throw a bucket of water in the ocean, will the depth change? Of course, it changes a little bit, but can you measure it? No. So that's where clean rooms are important. So clean rooms can help you collaborate with your digital or external publishers and then help you measure your digital campaigns as good as you measure your email and direct mail campaigns. So you have an advertiser layer, that's you, or if you're working for an advertiser, you have a publisher layer here. Like it can be you if you're working for Meta or Google or any other retail media networks. So you have these clean rooms in between. So these clean rooms, there are several types of clean rooms. So some advertisers, they can have their own clean rooms. If the publisher is willing to share their data, mostly they don't. And then the publishers like Facebook and RMNs and Google, they have their own clean rooms called walled gardens. And then if the advertiser is okay to send the data there, some don't. But there are these neutral clean rooms from LiveRamp and Newstar, so many companies doing this. So this is where all the data is merged and then they strip off all the PI information in there. So they try to make it as safe as possible. Some new clean rooms are evolving where you don't really move the data, you just exchange the metadata and then join the data between different partners. So this is where you can set your experiments at an audience exposure level. So no, you no longer need to worry about the entire file. You just take that final subset of people who are exposed to that, like 100,000, 200,000, or 1 million. Now you know who's truly exposed. Then you set up your control group. Control group can come from a placebo experiment you run, or you can do some synthetic control matching. This is where you get to the bottom of your experiment and then measure the true incrementality. This field is evolving from a data privacy standpoint and then security standpoint. And also, this will evolve to a point where multiple publishers can share their data together in this clean room. And then you can also evolve this into a cross-channel measurement. For example, if you're running multiple campaigns in multiple platforms, you want to see the interaction between your marketing touch points, right? You don't want to just know the impact of Facebook. You want to know, what about sending an email first and then direct mail and then the Facebook and then the Google, how these different channels are interacting together. This space is evolving. All the technical concepts remain the same, the synthetic control matching, A/B testing, geo-testing, but the clean rooms will give you access to the ability to join your data with these external publishers. And then you can analyze all these digital campaigns as good as you're analyzing your direct mail and email campaigns. Yeah, so that's all I have.
You talked about SEM and SEO when you were talking about like that slide. How do you account for cannibalization? Like if you're looking for SEM about the people that, search for it and would have clicked anyways through just like your SEO, how do you like take that into consideration when you're conducting that research?
So we know there's cannibalization. We have used some past data where we were running some experiments. We have some prior experiments where we went dark in SEM. So we have some evidences of how that cannibalization happened. So we use those calibrations in this model. But the actual cannibalization happened in this because if you want to do that in this analysis, you have to do a third cell where you don't run any SEM at all, which was not possible in this case. But we use some calibrations from prior analysis.
In general, if somebody was promoting digital to drive in-store traffic, right? How would you measure the connection from online to offline?
If you are running those campaigns on your own and operated media, right? Like if you're running a direct mail or email campaigns, the customer IDs. You can always link your customer ID back to the in-store transactions, right? You can easily do that. If you're running digital campaigns on Facebook or Meta, it's not possible without someone sharing data with Facebook or Facebook sharing data with you. So most of all this digital tracking is done through pixels. So if you're an advertiser, Facebook or Google or any other digital media, they set pixels on your website. So they can only track whatever the pixels can track. So pixels can track most of the transactions happening on a website, and also app. There are device IDs they can leverage. But if you with the Apple ATT new rules, like 75% of the device IDs are anonymized, so they cannot track that. So and then in store, there is no way unless you have an app where people are using app to purchase in store. Most stores or advertisers, they don't have that, right? So that's where you need the clean rooms I mentioned, which are evolving, where you kind of send your impressions or exposures data from your digital campaigns, and then you use your transaction data in the clean rooms and then do that join. And then you can get the entire 360-degree view of where your customers are buying after being exposed to the ads.
So the credit card transactions, perhaps from an in-store, right, would be fed into the clean room and you could match. But also, isn't it true? I mean, I know you asked about in-store sales, but isn't it true that many retailers, like what you work with, are driving so much more online, right? And even retailers that you wouldn't expect to be heavily online are in fact big online, right?
But still, like, a lot of transactions are still happening in the club. So you need to look at the impact of your media in the store as well. So for digital campaigns, that's a challenge right now. So most data savvy retailers, so they use clean rooms right now. So without that, you cannot really measure impact in the store.
How about career questions? I mean, Rajeev has a stellar career of applying data science through business and retail and online. Any questions for what it's like in the real world, or what he's doing, or where he's been?
Your long and hopefully rewarding, career so far, what do you think is like the stage or the position that gave you the most growth in both, mainly like more focusing on the technical aspect of it, where you feel like you learned the most and hopefully just share some tips?
I was able to work for a smaller retailer in the beginning of my career, called Office Depot. So I didn't get it was a junior role when I started. I would say that's the most rewarding because I never studied marketing in my career. I studied data science and operations research and all those things, but Office Depot gave me that opportunity to work in marketing, and then they taught me all the basic skills, from the business point of view. So that was really good. And then after joining my current company, I was able to move roles like every 18 months. Was able to work with different people in different parts of the business. The most rewarding was when I was able to build these products, right? Because previously I was just focusing on analysis, which was good. But after I was able to work on platforms where I was able to help the business while I was sleeping, and then all these platforms were running in the back end, and then a lot more analysts were able to use those platforms and then create like a broader business impact. That was really rewarding for me. I still try to build those products so that your products are running all the time with or without your intervention, and then create meaningful impacts, which are scalable.
Throughout your career, what would you say would be your biggest challenge?
Biggest challenge, that's not solved yet. So I don't work for an advertiser right now. I work for a media business right now. So biggest challenge is trying to connect the dots across all the media channels running for an advertiser, and then look at all the interactions that are happening without having to worry about missing data or anything. So I hope I can solve that problem at some day. I think this is a challenge for a lot of the marketing data scientists. So I was able to solve that a little bit, but as we get into the more advanced data clean room techniques, the data clean room platforms, I think I'll be able to solve that problem.
Yeah, talking on that. So with the rise of like clean rooms and kind of walled gardens, what do you think is the future of personalization and like accurate targeting when we have less info? Like when you look at GDPR and all these things that are kind of limiting the info that digital marketers are going to have to target consumers, what do you see the future of that being as someone that's in such a high position?
Yeah, it can't. Yeah, it's hard to say anything concretely right now. This is an evolving space. So whoever has the first party data, they'll be the winners. So previously, like Facebook and Google, they used to have a lot of data. With a lot of these privacy rules, like they don't have as much as data they used to have before, but a lot of retailers have much more data compared to all these digital platforms, right? So they have all the power to do better personalization, more personalization than these other digital platforms, because the transactions are happening on the retail side versus just browse and engagement happening on the digital side.
So you think it's going to be like a lot more in-house agencies that end up being created because there's no need for that third party?
Like media, not necessarily, right? So like the brands are actually the ones promoting the products. Like retailers do some promotion to improve their top lines, but there are also brands, right? Like they're also promoting. So they'll work with they'll work closely with retailers than directly working with these digital platforms, because there's more data on the retail side. Yeah, I cannot give you a lot more specifics about it, but data is the king, right? So who has more data? So right now, retailers have more data. Thanks for the opportunity. Nice to meet you all. We'll talk to you soon. Bye-bye.